Right. Good morning, good people. Once again, welcome to the grade 9 mathematics class. And I hope that we will have the chance to answer or ask any questions, be it through the chat group or the group chat rather, or you can also use your mic by raising your hand, and we will be able to identify your hand and then, give you the opportunity to answer or ask any questions. And today, I just want to continue with our lesson on Pythagoras. And just to recap what we spoke about, we are just investigating the relationship between the lengths and the sides of a right-angled triangle. And of course, we also want to determine whether the triangles are right-angled or not. And lastly, we need to calculate the missing lengths in the right-angled triangles. But today, of importance, I'm going to expect you to classify triangles. So I'm going to give you a triangle with different lengths, and then you will have to classify. In other words, you'll tell us whether this is a right-angled triangle or whether it is an acute angled triangle or rather obtuse angled. So we know that usually the sides will not be equal. There will always be the bigger side, particularly when we talk about the right-angled triangle. So basically, we already know the square of numbers. We have done that in order to get the square of a number. We know that you simply multiply a number by itself, and that actually gives you a square number. And just to recap on that, I've said that if you have an example of this nature, 3 squared, this will give you 3 multiplied by 3. And I'm deliberately repeating this example because I want you to remember the importance of the square numbers when it comes to the theorem of Pythagoras. And I know that some of you expressed a reservation, and I'm going to answer your questions today just to thoroughly explain this process. And of course, you'll recall that we also looked at 7 squared. We said that when you have 7 squared, this is the same as multiplying 7 by itself. And then 7 times 7 will give you 49. So basically, that is what we got. And the last one, of course, was 3 squared plus 4 squared. Now, if you add the square numbers, you must start by simplifying the square numbers. For instance, 3 squared is the same as 3 times 3, which is 9. And 4 squared is the same as 4 times 4, which is 16. And of course, if you add 9 and 16, you will get 25. So therefore, 25 will be your answer in that case. Let me just zoom directly into the expressions. We have simplified some of this. We also know that 8 times 8 is 64, and then we have simplified the squares just to, when we reflected last week, just to start with our Pythagoras. And then 11 squared, again, is another form of a square number. And then the other one, of course, was the 3a all squared, which we multiplied as and found 9a squared to be the answer. And then don't forget the cube root as well. In fact, the square root of yes, the square of a square root. If you square a square root number there, in other words, square root of 3 multiplied by the square root of 3, we said that it is 3. We have calculated this already, so you don't have to do it again. And then, of course, the other one will be the last one, where you had to now subtract 9 from 25 in order to get 16. So, and then the square root of 16, we said it's 4, and then 4 squared is 16, back to 16. So basically, those are some of the lessons that I want us to look at. And of course, we have done this, but equally, we defined our right-angled triangle as follows. We said that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So if you are given a triangle, just like triangle ABC, or the blue triangle rather, then you can be able to see that this will give you C squared, which is equal to A squared plus B squared. And basically, this is what we have done in as far as this particular concept is concerned. Right, excuse me. Just to join the mic once again. So basically, that is what we know in as far as this particular concept is concerned. And then again, we have thoroughly looked at how Pythagoras came up with a conclusion that if you take the square on the hypotenuse side is equal to the sum of the squares of the other two sides of a triangle, and not just a triangle, but a right-angled triangle. So this is what you need to remember, that a right-angled triangle, that's where you can easily define Pythagoras, or rather what is known as the theorem of Pythagoras. And of course, we know by now that A squared plus B squared will give us a C squared. Those are, if you ask, those are the squares. Those are the areas of the squares. Remember that the area is length multiplied by length. And then, of course, you multiply the areas of all the 3 squares. And the 2 small squares, if you add them together, they will be the same size as the bigger square. And this applies across the board. So in other words, it applies throughout the mathematics, all equations that you can think of. The theorem of Pythagoras applies if and only if you do have the right angle or the right-angled triangle, which consists of the hypotenuse side as well as the other 2 sides. We call these legs the legs A and B. We say that they represent the legs of a right triangle, and C represents the hypotenuse side. Now, this is what we have done when we looked at Pythagoras, but at the same time, we have been able to demonstrate that one of the sides should be perpendicular to the base of the triangle. So the hypotenuse side, always, all the time, the hypotenuse side is opposite 90 degrees. So it is opposite the right angle. 90 degrees is also known as the right angle. So right angle there, 90 degrees in size, those are the sides. And of course, as always, we define A squared plus B squared as being equal to c squared. In this triangle ABC, as you can see, the hypotenuse side there is AC, and the other two sides AB and BC. So if you square the two, the sum of the squares of those two sides will be equal to the square on the hypotenuse side. So basically that is how we have defined the theorem of Pythagoras. And we did not even end there. There was an example that I gave you, which is an example where you needed to find the hypotenuse side. And of course, as usual, we know that a squared plus b squared is equal to c squared. But remember that you can put the c on the left-hand side of the equation and make it the subject of the formula. So therefore, c squared is equal to a squared plus b squared. In this instance, all that you needed to do was just to substitute. And what is important is to substitute correctly, because the two other sides will constitute square numbers. For instance, 5 squared is a square number as well, and then 7 squared as well. So 25 is a square number, and 49 is also a square number. So when you add the two, when you add 25 and 49, you get 74. So 74 is the answer there. So meaning that 74 is actually the area of the bigger square. And when you want to find what the side is, one of the side there, which is the hypotenuse, you now square the 74 in order to get 8,6023. So approximately that is the value of C. And you get this, or you obtain this by using Pythagoras. So you obtain this by using Pythagoras. And then the last one, of course, is 9. And then 9 squared plus 11 squared there. So remember that x squared will be equal to 11 squared plus 9 squared. Once more, that is Pythagoras. This happens if and only if the 90 degrees is the angle which is opposite the x there, which is now our hypotenuse side. So basically, that is what you have. And then you should know by now, even though we rushed it the last time, but you should see that if you add 121 and 81, you get 202. So the final answer will be the square root of 202. And as you should know by now that the square root of 202 will give you 14,21. So basically, that is what we mean. So like I said, I'm going to give you some work on Pythagoras today, but I thought that I must take you through what we have done when we defined Pythagoras. But we have equally managed to show this in different ways. So I've shown you the theorem in different ways. If you look at the first leg there, we say this is the leg of the right triangle. That is the one that is perpendicular to the second leg, also known as A there, which is perpendicular to B. How do we know it's perpendicular? Or what is a perpendicular line, if I may ask? It's a line that forms 90 degrees when it is joined with the base. So you can see that A, where it meets the base, an angle is formed, and that the size of that angle is 90 degrees. And the last one, of course, is the hypotenuse side, which is definitely opposite the 90 degrees. So this describes the theorem of Pythagoras, which gives us the relationship between the lengths of the legs as well as the hypotenuse of a right-angled triangle. Right, and that was that. To proceed, we gave you an activity there. I gave you an activity and I said to you, if a triangle ABC has AB, which is 7 meters, and AC, which is 8 centimeters, and BC equal to 8 centimeters, is A, B, or C the biggest angle? Justify your answer. So I want us to quickly mark this activity by justifying our answer. I think we ended up having this as our homework last week. If triangle ABC has got 3 sides, the side AB is equal to 7 meters and the side AC is equal to, excuse me, and the side AC is 8 centimeters and BC also 8 centimeters. So you can see that AC is equal to BC. So now the question that I want to ask is A or angle A, angle B or angle C the biggest? Justify your answer. That is what I want to know. Which angle is the biggest between the 3? And justify your answer. I think that is the starting point for today. If you have seen what I did in Pythagoras, I've shown you the hypotenuse side, and then of course we know that the side that is opposite, or the angle rather, which is opposite the biggest side will be the biggest angle. So it will definitely be the biggest angle. Can we try and answer that? Right, firstly, we need to convert the 7 meters to centimeters. Remember that 1 meter is equal to 100 centimeters. So therefore, 7 meters, you simply multiply by 100 in order to get 700 centimeters. Okay, so 7 meter there is equal to 700 centimeters. So basically, AB is equal to 700 centimeters. And since it is opposite angle C, then it means that angle C will be the biggest. The other 2 sides are equal. So as you can see, they are less in size than side B or AB rather. Therefore, the biggest angle will be C. So C is the biggest angle. That is how we have concluded this, that C is the biggest angle. Why is it the biggest? That's because it is opposite. The opposite side is also the biggest side. So you must always remember that the smaller the side, the smaller the opposite angle. That is what I can tell you. And the bigger the side, the bigger the opposite angle. So the more you increase the side, then you are automatically increasing the angle. That is what I can say. That when you increase the side, you automatically increase the angle. So now, we are also asking a question here. What type of triangle is triangle ABC? So what type of triangle is triangle ABC? Remember, we have done Pythagoras, and I've managed to show you that in order to conclude that a triangle is right-angled triangle, the square of the hypotenuse side will be equal to the sum of the other two squares. Yes, no, Sipo? All right, let me unmute you there. Excuse me. Right, please go ahead, Mosipo.
Oh, good morning, sir.
Morning, Mosipo.
Sir, so triangle ABC is an isosceles triangle.
Okay.
Because it only has two equal sides.
Exactly. So triangle ABC will be an isosceles triangle because it has got two equal sides. Thank you very much indeed, Nosipo. That is the correct answer. So we can conclude that the triangle is an isosceles triangle basically because the two sides are equal. So remember when we defined a wide range of triangles, we came across a triangle which has got only two equal sides. And therefore, that is the isosceles triangle. So basically that is the isosceles triangle which we are talking about. Right. We are now proceeding to the next slide. Just to say, yes, undoubtedly, triangle ABC is an isosceles triangle. That is what it is. Triangle ABC is an isosceles triangle. The reason being the two sides are equal. Now, I've got an activity here which I spoke about, which I wanted to give you. And then we have got a triangle PQR. And of course, in A, we are told that P is equal to 12 centimeters and Q is 6 centimeters and R is 9. So we need to classify these triangles. What we need to do is to classify the triangles. So I want us to spend the next 10 minutes or so classifying these triangles. So let's make it 12 minutes because there are 6 of those. So let's spend rather 2 minutes or so to classify the first triangle. So the triangle PQR is just one triangle, and then we're changing the sides. For instance, you can see that in B, we have changed now the side of P to become 5 centimeters. So I'm going to demonstrate. Let me take one as an example. Let me use A as an example so that you can see what is it that is required. Let's take A. So in A, you can tell now that we have got 3 sides of the triangle, and then P is equal to 12 centimeters, followed by Q, which is 6 centimeters, and the last one is R, which is now 9 centimeters. All right. So in Pythagoras, we know that the square of the longest side must be equal to the sum of the squares of the other 2 sides. That is what we know when it comes to Pythagoras. So we are going to now apply Pythagoras. Why do we apply Pythagoras? Because it will definitely show us, we will be able to see what type of a triangle the PQR is. So we know that these sides are not equal. You might as well conclude that this angle is a scalene. Yes, if you say that the triangle, if you say to me now triangle PQR is a scalene, I will fully agree with you. That's number one. So if you can look at all the triangles in A, that's a scalene as well, and then B, that also is a scalene. C, also a scalene, and then D is also a scalene. E as well is a scalene, and the last one, which is F, also a scalene. I agree with you. All of these triangles are scalenes. But what type of a scalene? Is this a right-angled scalene triangle? Is it an acute angled scalene triangle? Or is it an obtuse angled scalene triangle? That is what I want when we classify these triangles. And as I said, I'm going to use A as an example so that when you look at others, at least you have an example. So let's start with A now as an example. All right. So now, when it comes to A, you can see that, as we said, P is the longest side. And what is that longest side? It's 12. All right. So P is 12. And that is the longest side. Therefore, when you apply Pythagoras, you are going to say 12 squared will be equal to the sum of the squares of the other two sides. Okay? So remember that the 12 is one of the sides, which is P is the longest side. What are the other sides? The other side is Q and R. And Q is 6 centimeters and R is 9. Therefore, you will say 12 squared is equal to 6 squared plus 9 squared. Why do you do this? Or why do you put 12 squared equals to 6 squared plus 9 squared? That is because in Pythagoras, we know that Pythagoras, the longest side is the hypotenuse side in Pythagoras. So we have to test whether the two sides will be equal. If the two sides are equal, then we know it's a right-angled triangle. But if the two sides are not equal, then it's either we are talking about the acute angled triangle or the obtuse angled triangle. And I'll come to that. I'll come to the acute and the obtuse. Now let's finish or finalize this equation. We all know by now that 12 squared is equal to 12 times 12, which is 144. So the left-hand side is equal to 144. That is what the left-hand side is. And let's go now to the right-hand side. The right-hand side, you have 6 squared, which is 36, plus 9 squared, sorry. 9 squared is 9 times 9, which is 81. And thereafter, you add the 2. 81 plus 36. And then you can see that if you add 81 and 36, you get 117. Therefore, 144 is not equal to 117. I'm sure you agree with me. That is why I've put in the sign there. I've said, therefore, the left-hand side is not equal to the right-hand side. So the two are not equal because the left-hand side is 144 and the right-hand side is 117. Now, we can make a conclusion based on this. 144 is obviously bigger than 117. So if 144 is big, it means that angle that we are talking about, the P is the biggest angle. And that is why we say the type of triangle here will be an obtuse angled triangle, but not just an obtuse angled triangle. It's an obtuse angled scalene triangle. Yes, Nosipo? Please go ahead.
So you can continue. I wanted to do the second one, but since you're busy with the first one, you can continue. Then when you're done, I can unmute myself and do the second one.
Okay, no problem. Thank you very much. Right, I think we are done with the first one here as an example, and then of course we can proceed to B, and thereafter do
Yes,
C
so
as
that's the
well.
one that I wanted to do.
Okay, can you go ahead with B? Just tell me what type of a triangle is that?
So it's a scalene.
Yes, definitely it's a scalene. But what type of a scalene? Is it acute angled? Is it right angled? Or is it
It's a
obtuse angled?
acute angle. It's an acute angle scalene triangle, sir.
Why do you say it's an acute angled scalene triangle?
Because I calculated it and I got that the final answer is less than 90 degree.
Okay, how did you calculate your how did you do your calculation? Just tell me.
Okay, so I said 9 squared equals to 8 squared plus 5 squared.
Okay, great. That's a great step, yes.
And then so the second step was 9 squared equals to 81, and then 8 squared gave me a 64, and then 5 squared gave me a 25. And then when I calculated it, 81 is not equal to 89. How did I get the 89? I said 64 plus 25, and it gave me 89. So 81 is not equal to the 89.
Okay. Yes, I fully agree with you. If you do your calculations, you'll see that the left-hand side will be 81 and the right-hand side will be 89. Remember that 5 squared is 25 and 8 squared is 64. So if you add the two, if you add 64 and 25, you will get 89. So 89 will be the answer there. I fully agree with you. So an acute angled scalene, that is the correct answer there. I fully agree with you there. Thank you very much indeed. Thank you very much indeed, because the right-hand side will be bigger than the left-hand side. So let's go to C. Let's go to C, where P is equal to 25 and Q is 13, R is 12. Let's go to 13. So I'm going to C now. You can see that P is the biggest or the longest side. So it means you are going to square the 25, and then you'll also square 13 plus 12 squared there. So you'll have 25 squared, where you multiply 25 by 25, and then you multiply 13 by 13, you add it to 12. Yes, once more, Nosipo. Please go ahead.
Okay, so for the third one, I said I took the 25 because it's the bigger number, and I said 25. Okay, 25 squared equals to 13 squared plus 12 squared.
Great step.
And then I broke it down, sir, and then 25 squared gave me 625. And then the 13 squared gave me 169, plus the 12 squared gave me a 144. So on the left hand side, I have the 625, and on my right hand side, I have the 169 plus 144, which is equals to 313.
Okay.
Yes, sir. And then so it's also not equal, but the triangle is an obtuse angle scaling triangle.
Exactly. Exactly. Obtuse angled triangle, scalene triangle, because the left hand side is bigger than the right hand side. Great. Great. I saw Unkabetse, your hand was up, and let me recognize you now for D. Please go ahead, Unkabetse. Even if you have a question, it's fine. You can carry on.
Good day, sir.
Good chat. Okay, Unkabetse, you can carry on.
Good day, sir.
Good day, Unkabetse.
I wanted to do C, but I can do D, sir.
Okay.
So I took the longest side, which was 9 centimeter, and I made it a 9 centimeter squared is equals to 8 centimeter squared plus 5 centimeter squared, which I'm not sure if I'm correct or not.
Okay, just are you doing D now?
Yes, sir.
Okay, and then in D, which one is the longest?
9 centimeter.
Okay, so you said 9 squared is equal to 5 squared?
81. Yes, sir. I said 9 centimeter squared is equal to 8 centimeter squared plus 5 centimeter squared, which
Great,
is
that's
80,
the right step.
which is 81 is equals to 64 plus 25, and which makes it 81 is equals to 89. They are not equal.
Okay. And what type of a triangle is this?
The triangle is an acute triangle.
Exactly. So the triangle will be an acute angled scalene triangle. Remember, we agreed in the beginning of the activity that all of these triangles will be scalene, but you just have to demonstrate what type of a scalene. Is it an acute angled? Thank you very much indeed. That's an acute angled scalene triangle. Thank you so much, Unkabets. That's the correct answer. And that was D. Can we proceed now to E? Can we proceed to E? Yes. Some of you can also do it in the group chat. Who is speaking now?
Nosipo.
Okay, please go ahead, Nosipo.
Okay, so for E, I took the longest side, which was 15. Yes, it's 15. Okay. And then I said 15 squared equals to 9 squared plus 12 squared. Okay. And then the 15 squared gave me a 225.
Okay.
And then on my right hand side, sir, I took the 9 squared and the 12 squared, which gave me 81 plus 144.
Okay.
And then on the left hand side, I have my 225, and on my right hand side, I have my 81 plus 144, which when I add gives me a 225. So the 225 is a right angled scalene triangle, and it's equal.
Great. Thank you very much indeed. I'm glad that you can see the type of triangle that we're talking about. So it will be triangle PQR will be the right angled scalene triangle. For the simple reason, the left hand side is equal to the right hand side. So the left hand side and the right hand side are equal. So this means we are now satisfying the correct values of the scalene, not the scalene rather, but the so so now that satisfies. I must apologize about the noise in the background. I was just trying to get that done away with. So the right angled triangle or the right angled scalene triangle is the correct one. So can we quickly talk about the last one just before we close our class? The last one quickly. You can see that in the last one, we have 9, which is now the biggest side.
I also did that one, sir.
Okay, can you conclude on that one, please?
Okay, so it's the longest number is 9, so it's going to be 9 squared equals to 7 squared plus 6 squared.
Okay.
And then the 9 squared is obviously 81.
All
And
right.
then 7 squared is equals to 49, and 6 squared is equal to 36. So on my left hand side I have 81, and on my right hand side I have 49 plus 36, which gives me 85. So in this case, 81 is an acute angle scaling triangle, sir.
Exactly. So 81 is less than 85, which means that our triangle will be the acute angled scalene triangle. So this actually brings us to the end of our activities for today, where we were able to classify the different triangles there, which are given. So I hope that this has brought us to the end of the lesson. And once more, as always, our lesson is brought to us by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.